Greetings, class. Let's start this class by asking yourself, what do you think the word statistics means? Is it some kind of data or numeric information, or some sort of sense-making of numbers? All of these answers may be partially correct. Regardless of your interpretation of statistics at this point, in this course, we're going to talk about statistics applied to the behavioral and social sciences. Within this context, statistics is a tool used to answer research questions. Treat today's class like a second language lesson because you will need to master statistical vocabularies such as variable, value, data, measurement, population, and sample. It's easier for me to start with a hypothetical research question and walk you through the basic concepts in statistics. Let's say my research question is whether adolescent girls and boys spend different amount of time on social media. Most likely, when I ask this question, I have a suspicion that there is a difference, and I need to verify it with evidence. Based on this research question, you can tell that the population I'm interested in is adolescents. To answer my research question, I need to collect data from adolescents, boys and girls. Will I be able to collect data from all adolescents in the world, in the United States, or even only in the state of Tennessee? Not really. I am limited by my time and resources. What do I do then? I must get data from a subset of the population. For example, I may ask the superintendent to distribute a survey to middle and high school students in Memphis City schools to collect voluntary information about their social media use. Even if this were possible, I would still only have a small group of adolescents from the entire population. The process of selecting a subset of the population is called sampling. If you recall from EDPR 8521, there are probability sampling and non-probability sampling procedures. The difference is whether individuals in the population have an equal probability of being selected into the sample. A random sample is one type of probability sampling. Convenience samples or volunteer samples are examples of non-probability sampling. Once I gain access to my study sample, I can use instruments to collect data and then enter the data into my computer. Based on my research question, the two pieces of information I need are the amount of time spent on social media and gender. Gender is straightforward to capture, but I must decide how to measure the amount of time. Should I ask about the average number of minutes per day or the total number of hours per week? This process of deciding how to collect information about a specific trait is called operationalization. The pieces of information I'm collecting are called variables. In this example, I have two variables, gender and the amount of time spent on social media. Gender may have values such as male, female, and non-binary. For the time variable, if I decide to measure the average number of hours spent per week, the values will be numerical. Some students confuse variables and values. A variable is a characteristic that can take on different values. For example, gender is one variable with 3 values in this case. It's incorrect to say you have 3 gender variables, male, female, and non-binary. If you only collect data from girls, gender becomes a constant, not a variable anymore, because all participants have the same value. On this slide, the spreadsheet on the right shows how a data file looks like. In the data file, each row contains all the information from one observation. So the number of rows, excluding the title line, equals the sample size. Each column represents a variable. In the gender column, for example, you can see there are 10 boys and 11 girls. Now, let's discuss measurement. Measurement is the process of assigning numbers to the characteristic you're capturing according to certain rules. The degree of precision in your measurement determines the measurement scale of a variable. Suppose that I added 2 more variables, physical activity levels and BMI, in my study. For physical activity, I might ask students to self-rate as high, medium, or low. Alternatively, I could ask them to report the number of minutes they work out on each day, which would give a more precise measure. Why is knowing the measurement scale important? Because down the road, it determines which statistical method can be used to analyze the data. There are 4 different measurement scales. First is nominal, which assigns numbers to groups, but the group numbers are just labels without numeric meaning. In my example, I use 1 to represent boys and 2 represent girls. Move up a level, we have ordinal variables. An ordinal variable have ordered categories where the distance between the values are not necessarily equal. An example of an ordinal variable could be the pain ratings from 1 to 5. Interval variables have values that are ordered and the distance between neighboring numbers are equal. So we can say the difference between 15 and 20 apples is the same as between 3 and 8 apples. 14 women is 40% more than 10 women. The most refined measurement scale is ratio. A ratio variable has the same property as an interval variable. In addition, it permits proportional or ratio comparison and has an absolute 0. Age, income, and temperature are all examples of ratio variables. You may also hear quantitative variables and qualitative variables. A quantitative variable has values that represent the amount, such as height, weight, and age. So both interval and ratio variables are quantitative variables. They are also called continuous variables. A qualitative variable is a collection of values where the values represent groups and do not indicate more or less of a certain quantity. So nominal variables are definitely qualitative. They are also called categorical variables. Once the data is ready and we are clear about the measurement scales of the variables, we can begin descriptive and inferential statistical analysis. The first part of this semester, we'll discuss in detail about generating descriptive statistics, and then I will introduce you to inferential statistics. We run descriptive statistics with the sample data. The goal is to summarize, classify, and describe data. Descriptive analysis enables us to understand the sample before moving forward to making inferences about the population. Inferential statistics use sample data to make estimates or draw conclusions about a population. For example, it's unlikely that we know the average amount of time adolescents spend on social media in the population, even though it is a real value out there, simply because we don't have access to all adolescents in the population. So the best way to estimate their time on social media is based on what we know from a sample. Inferential statistics provides us the tools for making inferences. One thing you need to remember, and I will keep asking you, is whether statistics can be used to prove anything. The answer is no, because we only have information from a small fraction of the entire population, and we try to make inferences about the population characteristics based on probability estimates. We can use statistics to provide evidence, but can never prove anything because our conclusions are based on probability and are subject to error. Finally, let's distinguish between population parameters and sample statistics. A parameter is a value describing the entire population. For example, the true average time adolescents spend on social media is the population mean denoted by a Greek letter mu. A sample statistic describes a sample. For example, the sample mean is denoted by a capital letter X with a bar on top. Each parameter has a corresponding sample statistic. Later on, we'll talk about population variance, which is sigma squared, and the sample variance, S squared. Before you go, remember that EDPR 78521 is a prerequisite for this course. If you have not taken it, you are welcome to sit in for a couple of weeks to decide if you're ready. One key concept from that course, in addition to other concepts that we have reviewed today, is the distinction between independent and dependent variables. Independent variables are those that are observed, controlled, or manipulated according to the study's objectives. Dependent variables are the outcomes that are measured and assumed to be affected by the differences in the independent variables.